This lesson is going to be on the law of sines. Let's start by considering a general triangle. Now, let's label the vertices and the sides. Now, let's construct an altitude from the vertex C to the side AB. And we'll label the length of that altitude h. Now, if you look at our original triangle ABC, you'll see that the altitude has divided that triangle into two right triangles. Now, because of that, I'd like to take and get an expression for h in terms of angle A. Well, if you look at it closely, you realize that is a right triangle, and I can use the trig function sine. So the sine of angle A would simply be h over b. Now, if I multiply both sides by b, I get h is equal to b times the sine of A. Now, I want to look at the other side of my triangle and get an expression for h in terms of angle B. And much like I did on the left side, I get that the sine of angle B is equal to h over A. And now, if I multiply both sides of my equation by A, I get an expression for h, that h is equal to A times the sine of B. Now, if you look, I have two equations or expressions for h. I have h equals b sine A and h equals a sine B. Well, I can simply combine those two and set them equal to each other. So b sine A would equal a sine B. Now, if I divide both sides by A and divide both sides by B, I'm going to get sine of capital A over little a is equal to sine of capital B over little b. And what I have developed here is the law of sines. Now, this is true for any triangle. As you recall, we set this up originally as just a general triangle, ABC, and so this is true for any triangle. Now, what we could also do is extend this, and if we were to include an altitude from B to AC, we would find that we could add to this that the sine of capital C over little c is equal to the sine of capital A over little a. So the complete law of sines will now read sine of capital A over little a is equal to the sine of capital B over little b is equal to the sine of capital C over little c. Or to put it another way, we could say that for any triangle, the sine of any angle of that triangle divided by the length of the side opposite that angle is equal to the sine of one of the other angles of that triangle divided by the length of the side opposite that angle. Okay? Now, this can be very useful because if we have a situation where we have one angle and three sides, we could easily figure out what the other two angles are by means of the law of sines. So let's look at an example to show how this is useful. So let's assume you're given a triangle PQR, and you know that PQ is equal to 6, QR is equal to 7, and angle P is equal to 30 degrees. And you're asked to find what is the value of angle R. Well, here's a perfect case where you can use the law of sines. Now, using the data you have from this triangle, you could set it up and say that the sine of 30 degrees divided by 7 is equal to the sine of angle R divided by 6. Then, if I multiply both sides of my equation by 6, I'll get sine of R is equal to 6 times the sine of 30 degrees divided by 7. Now, if you crank out the numbers, you'll see that the sine of 30 degrees is equal to 1/2. And if you plug that in, you end up with sine of r is equal to 3/7. Now, if you use the inverse trig function, you can get that angle r is equal to the inverse sine of 3/7. Now, inverse sine can also be expressed as arc sine, or in this case, a sine. So if you use the calculators, we can figure out what angle r is equal to. And this yields angle r is equal to 25 degrees. Now, this concludes this lesson on the law of sines.